In this video, we will solve a bearings problem that requires the application of trigonometric rules. That's basically the sine rule, cosine rule, or sometimes even just the trig ratios, depending on the situation. This is a past paper question in a calculator with calculator. So let's get started. The diagram shows a position of two ships A and B and a coast guard station C. So the diagram is given to you. It's not to scale. That means don't use your protractor to measure the angles or a ruler. So calculate the distance AB between the two ships. Show that it rounds to 138 kilometer, correct to the nearest kilometer. You have already been given the answer. All you need to do is arrive at this answer. So basically show your working. How are you going to arrive at this answer? As we can see here, we have the distance from A to C is 95.5 and the distance from B to C is 83.1 kilometer. We are also given the angle between them, or the angle at ACB, which is 101. So this is your, you have two sides and an included angle. First of all, let's highlight the region, highlight what we are required to do. We are required to find out AB, right? This is what we have to find out, AB. So first thing is identify what is it, which rule of trigonometry that we will need to use. As I mentioned before, we have one side, we have the other side, and we have the included angle. So let's put here X. And we identify that we have to use the cosine rule. Why the cosine rule? Because two sides and an included angle. So what does the cosine rule state? The cosine rule states that, for example, if this is your missing side, right? So let's write AB squared is equal to the square, add the squares of the other two sides. So that is 95.5 squared plus 83.1 squared minus 2 times the same two sides, 95.5 times 83.1 times the cosine of the angle that is sandwiched between them, which is 101 degrees. Make sure your calculator is on degrees so that you get the correct answer. Once you arrive at the answer, you remember that you have to square root it, right? So AB would be the square root of the whole thing. Obviously, this should be in one line. All of them are under the radical sign, which would give us AB equals to 138.037. At this point, obviously, you'll use a calculator. And then show the entire answer because they said rounded to this. So the entire answer is important. And then you will round it correctly to the nearest kilometer, and that would round to 138 because this is your near, and the next number is a 0. So this is going to round to 138 kilometers to the nearest kilometer. So that is for this part. Now let's go to part B. The part B gives us further information. It says that the bearing of the Coast Guard C from ship A is 146. Let's mark this information on the diagram. So the bearing of C from A. So let's go to the point A. Let's go to point A. And then the line joining A and C, that's there. So let's draw the bearing from here all the way till here is 146 degrees. Let's mark that as well. And now what do they want? Calculate the bearing of ship B from ship A. That is again this point, but now it is only up till here. So they just want us to find the bearing here, this part, right? In short, if we were to be able to find out this tiny portion here in the triangle ACB or ABC, if we can find this portion and we subtract it from 146, we would solve our problem, right? So how do we solve this problem? Now we want to find this angle. What information do we have? In the previous example, we found out that this here, AB, is 138 kilometers. right? And we can use this information now. And which rule can we use for that? So we can see here, you have an angle and a side opposite to it. You also have a side here, and what we need is the angle that is in here. So we want to find this. So now, because it's this crisscross situation, we will be using the sine rule. How do we go about it? Since the angle is what we are searching for or answers for. So what sine, we put the angle on top. Sine 101. Calculator will use a bracket over 138 equals to sine of the missing angle, sine of, you can call it as BAC, or you can mark it with a theta, up to you, over 83.1. And then multiply this out here, take this to the side, which will get us 83.1 times sine of 101 over 138. But that would give us the sine of BAC, not the angle BAC. So to find BAC, the angle BAC, we would have to use sine inverse. So sine inverse of the entire thing, 83.1 times sine 101 degrees over 138. Plug this plug this in the calculator, and you should get your answer to be around 36.235. If you round it to 2 decimal places, depending on if something is mentioned, but it's an angle, so we round it to 2 dp. If it's a distance and nothing's mentioned, we round it to 3 sf. So here we'll go 36.24 degrees, right? If you're rounding it to 3 sf, it would be 36.2. So this, I have rounded it to 2 decimal places, right? So that is my angle BAC. But that's not what we wanted, or that's not what we are asked for. We are asked to find the angle, the bearing of B from A. To get that, we need to subtract this number from 146. So the bearing of B from A would be given by 146 minus 36.24, which is equal to 109.76. That's a bearing, so this is degrees, right? So we are done with that part. So that's the bearing of B from A. Now let's go to part C. Now part C, sorry. All right, now part C is not related. So now part C, where are we? So here at noon, this is the information that's given to us. At noon, a lighthouse L is 46.2 kilometers from ship B on a bearing of 21 degrees. Ship B sails northwest. This is your northwest direction. Calculate the distance the ship B must sail from its position at noon to be at its closest distance, this part, underline it, closest distance to the lighthouse. Now this requires prior knowledge that the closest distance is always the perpendicular distance. That means we have to draw a perpendicular from the lighthouse to, for example, let's say this the ship is sailing from B in the northwest direction. There it is sailing. And to find the shortest distance, we have to draw a perpendicular from here to here. So it has to be 90 degrees because that would be the shortest distance. So let's draw that. Okay, this approximately looks like a 90 degrees. So, okay. Here we have now drawn a 90 degree because this is a 90 degree. Now in this case, you can see that this is a right angle triangle, and we can use right angle trigonometry in this particular problem. So here now what do we want to find? Calculate the distance from its position to at which position will it be at its closest distance to the lighthouse. So this is the position that we require, right? This distance. Let's give it some name. Let's call it D. Okay. So now we have an angle in here. So that angle is going to be 45 plus 21, which is 66 degrees. We also know that this one is 90 degrees. So we can actually label this using the right angle triangle rules. So here, this one would be our hypotenuse, right? What we require is the adjacent. We don't need the opposite. So here we have the hypotenuse, we need the adjacent. We'll be using cosine, and the angle here is 66 degrees. So we have cosine of 66 equals to adjacent, which is missing. You can call it BD, you can call it X, over the hypotenuse, which is 46.2. So to find BD, which is the shortest, the closest distance to the lighthouse, we would do 46.2, take this to the other side, 46.2 times cos of 66 degrees, and that would give us BD. How far it has to sail on the, like on this bearing, right, in the northwest direction, so that it is the closest distance to the lighthouse. Now plug this in your calculator. Again, make sure that it is on degrees, and you would get your answer as 18.8 kilometers. So that is it for this problem, for this part of for these questions. You have to determine what you are required to find and apply the cosine rule, sine rule, or just the right angle trigonometry as is relevant to a problem. Another thing that can be asked is to find the area, just going over it very quickly. So if you wanted to find the area of this triangular region, what would it be? You would use the area formula, which would be so if you wanted to find the area, just so that we could quickly revise on the area formula, if you wanted to find the area, you would write by 2 times both the sides, 95.5 times 83.1, and here now you would use sine of the included angle. This is just a very quick recap, so you can go ahead and solve that in case area is asked. For certain problems they even ask that, but in this case it basically does not, I mean, this question does not merit that, but sometimes you're asked, in certain problems you're asked to find the area. So in case you're asked to find the area, this is how you can go about it. So that's it for this problem.